practical applications of the Bernoulli's equations? So what are the practical applications of the Bernoulli's equation? So basically my Bernoulli's equation practical application is used, Bernoulli principle is used in case of my Venturimeter, orifice meter and pitot tube. Okay. So what is my Venturimeter? So Venturimeter basically is a device which is used to measuring the rate of flow of the fluid flowing through the pipe. So basically it is a flow device is used to the flow rate of flow when my flow is flowing through the pipe. Okay. So what is my Venturimeter? It is a device used to measuring the rate of flow of a fluid flowing through a pipe, flowing through a. Okay. So if I'm drawing the basic Venturimeter, so this is my Venturimeter. It consists of three parts basically. First one is this is my converging part. Second one is my throat. And third part is my diverging part. This is my throat and this is my diverging part. Okay. And this is my inlet and this is my outlet. Okay. So if I'm considering the two section, that is my section 1 and in section 2, then if I'm applying the Bernoulli principle at section 1 and 2, then we can write P1 by rho g plus V1 square by 2g plus Z1 is equal to P2 by rho g plus V2 square by 2g plus Z2. Okay. So if my pipe is horizontal, in that case, we can write Z1 is equal to Z2. So my equation will be P1 by rho G plus V1 square by 2G is equal to P2 by rho G plus V2 square by 2G. So from this equation, we can get, I move this term from the left hand side and move this term from right hand side. So from this equation, we can write P1 by P2 by rho G is equal to V2 square by 2G minus V1 square by 2G. Okay. So what is this term is known as my pressure head, difference of pressure head at section 1 and 2. Okay. So if I'm equivalent this term as H, so we can write H is equal to V2 square by 2G minus V1 square by 2G. Okay. So if I'm applying the content equation at section 1 and 2, so according to content equation, we can write Q is equal to, according to content equation, the discharge is constant throughout the section. So we can write Q is equal to A1 V1 is equal to A2 V2. Okay. Or we can write V1 is equal to A2 V2 by A1. So if I am putting this value V1 in this equation, suppose this is my equation number 1. So what we get? So we get put the value of V1 in equation 1. So we get V2 is equal to A1 by root A1 square minus A2 square root 2GH. Okay. Or we can write the actual discharge is equal to CD A1 A2 divided by root A1 square minus A2 square multiply by 2GH. Okay, this is my actual discharge.